Hi everyone, my name is Peter Shields and on behalf of AirMet Scientific, I'm pleased to welcome you to today's webinar, Advancements in Respirator Fit Testing Technology with Controlled Negative Pressure. We're very pleased to have Dr. Stephanie Lynch, the Product Manager from OHD Global, to present today. We're really excited about the new Quanta Fit 2 and look forward to hearing more about it today. So I'll now hand over to Stephanie for the presentation. Thanks.
Thank you, Peter. So good morning, everyone, or at least I'm pretty sure it's still morning. I think I heard 11:30. I've unfortunately had several learning experiences over the last week about time zones. Luckily, I figured out in time that I was about to be an hour early for this one. But it's so nice to be here and to be presenting again with AirMet. It's been quite a year, and that is quite an understatement, right? So let's get rolling here. I want to make sure that we're all on the same page. So we're going to start right at the beginning. A fit test is when you use a set of exercises to assess the fit of a respirator on a wearer. And this involves the use of a challenge agent, and it's meant to do a bit more than simply find a respirator that fits. The process of fit testing is also meant to confirm a wearer's training in the use of their respirator, and I would contend it's also to promote their confidence in their ability to use their own protection, right? To exert a little bit of power control over their own protection and health. So the fit test can be performed qualitatively or quantitatively. And it feels like just a sick joke that they made those words so similar. But qualitative fit testing involves the use of a challenge agent that the respirator wearer can either taste, smell, or react to. And some popular challenge agents are banana oil, which has the smell of bananas, saccharin, which is sweet, and then Bitrix, which is a bitter taste. And then saccharin, actually, I will never forget the taste of because we used that at the hospital where I worked for years, and sometimes I still taste it in my nightmares. Irritant smoke is another method that is actually approved here by OSHA, but most people don't use it as it can be a hazard in and of itself. It actually does irritate the wearer. It can cause like skin irritation, eye irritation, stuff like that. So if the wearer can sense the agent during the test, then the fit is deemed unsatisfactory, but if they can't, then it's considered a pass. Qualitative fit testing can only be used for those respirators that have a reference passing fit factor of 100 or less. So there are some benefits to qualitative fit testing. It is relatively inexpensive and it requires very little maintenance. Unfortunately, it is subjective, as we just talked about, and the test can be cheated. I hate the way that sounds because I don't think there's just a bunch of people out there itching to cheat on a fit test. But for instance, at that hospital where I worked, I would fit test over 2,500 healthcare professionals a year, and 99.9% of them passed their fit tests. And I seriously doubt this was because of the superior fitting ability of the N95 filtering face piece respirators that we were using, or what y'all call P2 respirators we were using. It was because they knew that they needed to pass their fit tests in order to do their jobs, in order to be allowed to do their jobs. And that their jobs were important to them. And kind of almost in a very different way. And I imagine COVID has had some impact on this, but I kind of wonder in which direction. You know, we've seen so much altruism with those in healthcare that while some may be much more aware of taking their health and safety very seriously so that they can continue to help others, I feel like still others want to help, seemingly no matter the personal cost. Anyway, I'm going a bit down the rabbit hole here, so sorry, but qualitative fit testing, back to the point here, is also typically slower, and those pass-fail results are imprecise, right? It's not even really, you know, we're giving it that 100 level, but it's not really giving you a solid number. And you would also need to create your own records, a means of tracking all those fit tests and what the results were. So quantitative fit testing is when you're going to use a machine to objectively measure the leakage of a challenge agent into the respirator, and the machine is going to give you a numerical representation of that fit. That number is your fit factor. There are three typical methods, maybe I shouldn't even say typical, but three methods that are typically approved. Controlled negative pressure, CNP, ambient aerosol or condensation nuclei counting, CNC, and then generated aerosol. Quantitative fit testing can be used on any tight-fitting respirator. CMP will only work for elastomeric respirators, but I mean that they're not limited in application the way that qualitative fit testing is. So while this is why I felt a little weird about saying typical methods. I realize that's what I put on the slide, but that might not be the exact correct wording. While there is a portable method of generated aerosol fit testing, it's not very commonly used and it's quite cumbersome. So the two methods you'll likely see are CMP and CNC. So CMP is going to use pressure to challenge the seal, and so therefore air is our challenge agent. It measures the leak rate of that air in cc's per minute, and CNC is going to use aerosols that are present in the ambient air to challenge the seal. If your ambient aerosol counts are too low, then you can artificially create them, and the ratio of the aerosol concentration found inside and outside of the respirator is calculated. So quantitative fit testing is more expensive, and it does typically require maintenance. Usually that's an annual calibration, but it is objective, and it will create and maintain records, and it is also significantly faster. It's also what you'll have to use if you're using respirators that provide those higher levels of protection and require a higher reference fit factor. So any respirator that requires a passing reference fit factor of over 100. I mean, yes, of over 100. So of course, we are going to fit test ourselves and our employees to ensure their health and safety, but in many places, we are regulated to do so. Fit testing as part of a complete respiratory protection program is a way to meet your legal obligations regarding respirator use in Australia. ISO is the foundation for many regulations. In the USA, OSHA requires fit testing. ANSI offers guidance on fit testing, and there's a forthcoming European standard, although I believe it too is going to quite closely follow ISO, or at least it appears to so far. So when do we perform fit testing? So we want to initiate fit testing before we are even using respirators against any given hazard. And also we want to implement fit testing whenever we see or are made aware that an unfitted respirator is in use. I'm hoping that is becoming less and less common, but I think you would be surprised how often I hear about it. And also anytime we switch to a new brand or style or size of respirator, we're going to want to retest the fit of a respirator at the very least at the specified time interval given in whatever regulation or standard that we are following. And this is typically either annually or every other year. We also want to do this whenever a wearer loses or gains a significant amount of weight, although, good luck being the one to point out significant weight gain to any wearer that you may know, but also with any facial changes in that area where the respirator is sealing to the wearer's face. So ISO actually spells out some pretty good qualifications for who can fit test, but other regulatory bodies are much more vague, really. OSHA says almost Nothing. They simply specify procedures and record-keeping requirements. Luckily, there are some other organizations that are doing the good work of creating accreditation programs for fit test administrators. And you can also typically find some individuals and companies that are offering training on either respiratory protection program administration or on fit test administration itself. Locally, we have education research centers that offer those sorts of classes that are open for really anyone. You can do it as a company. In Australia, though, you guys are very lucky to have RestFit, which was officially launched in December of 2020. And I have had the privilege of seeing and commenting on the CMP methodology and testing for RestFit, and those guys just really deserve a pat on the back for especially for developing this through what has clearly been the apocalypse, but for developing this to benefit and protect respirator users. The process they're doing is really cool, so check it out. They let you send in a video of you performing the fit test on your selected methodology, and you send it in to get evaluated by assessors. They're also, I believe, still recruiting assessors. So just a really cool thing that RestFit is doing, really well developed fit testing training and accreditation. Okay, I better actually focus on CMP now. So controlled negative pressure, or CMP, is the patented fit test technology that's applied by the QuantaFit and the QuantaFit 2. It is the same technology that we have been using for over 30 years. It utilizes negative pressure as a direct measure of respirator leakage. The QuantaFit uses air molecules. I mentioned that air is the challenge agent. So that's utilizing those air molecules that have an ambient concentration in the septillions. And that's what we're using to challenge the respirator. So when we create and maintain a controlled negative pressure within the respirator facepiece, it's going to mimic the inhale of an average human working at a moderate rate. We are creating an environment that will have all of those air molecules fighting to get into that respirator in really in any way possible. So we didn't change anything about how we utilize CMP to test the respirator. So if you're familiar with this process, then it hasn't changed. But if you're not familiar, then to create and maintain a negative pressure, the user is going to take a comfortable breath and they're going to hold, and the adapter valve is going to close to seal the respirator. And this was previously accomplished with the trigger button on the legacy QuantaFit. And now it actually closes automatically with auto start functionality. So then the instrument's going to pull out air until it reaches that set challenge pressure that's associated with the breathing rate. It's going to do that within the respirator. And if no leak is detected, then the pressure is going to remain constant. And if leak is detected, then the QuantaFit or the QuantaFit 2 is going to work to remove air until that challenge pressure has been achieved within the respirator again. So it does this for 8 seconds, and during that 8 seconds, it is tracking the exact amount of air that it is removing, and that's how it calculates a leak rate. This is also what makes it a direct measure of leak. Our triple tube assembly has one line that seals off the adapter breathing ports, and then a dual tube with one side measuring any air that is leaking into the respirator, and another that is evacuating that leaked air to maintain the negative pressure within the respirator. So it'll be able to tell you exactly how much has leaked in. It's tracking that. So the QuantaFit 2, again, just like its predecessor, is going to convert the leak rate that it has measured into a fit factor. And it's going to do this by taking the model breathing rate and dividing it by that leak rate that it measured. And this is how you get each individual exercise's fit factor. So another way to look at this is that it's the ratio of the total amount of air inhaled to the amount of possibly contaminated air that's been inhaled. So that air that's coming through the leak. Just sometimes thinking about it as a ratio, if you're familiar with the ambient aerosol ratio, can kind of help a little bit conceptually. But so this is where it can get a bit confusing about the different quantitative fit testing methods and their fit factors. So once individual fit test exercise fit factors are for each method are calculated and what are their very different ways, all quantitative fit test methods then utilize a harmonic mean of those individual test exercises measured fit factors. So it's useful to utilize this harmonic mean because a harmonic mean places more weight on the lower values. And that's useful because with fit factors, we're wanting them to be conservative, right, from a health protection standpoint. So that's why we utilize harmonic means. But that just means that fit factors measured on the different technologies, methodologies can't be directly compared. So this is our protocol that is most often used with our technology, with CNP. So with our QuantaFit 2. And the read-on protocol is a 5-step protocol that involves the performance of these listed exercises followed by the measurement. And so when we talk about measurement here, we're talking about how you have to go ahead and take your breath. Then the machine is going to do that 8-second calculation where it's slowly removing the air, and then that's your 10-second measurement. So I get that it's kind of confusing, 10 seconds, 8 seconds. But so let's see this protocol in action. So these guys are Booth Armstrong. He's our national sales manager, and then the guy on the right is Luke Allen, and he is our president. And so they're going to go through a fit test, and you'll hear Booth for a quick second, but then he's going to roll into his fit test, and I'll be talking over him.
Absolutely. Let's show you a demonstration of the QuantaFit tape.
So what you're going to see here is Booth just donning his respirator, just making sure he's got a good fit. But what's going to happen next is, here in the States at least, we have to wait 30 seconds. That's the test exercise. And so Booth is performing that exercise, which in this instance is just normal breathing. So he's going to normal breathe for that 30 seconds. And then what's kind of cool here is, and you can't see it here well, that's why he keeps checking his watch, because we're at 30 seconds, he's going to take that breath. But so we'll see an up-close version of this, but on the machine behind him, you can see that the avatar is taking that breath too until Booth initiates that test. So when he took that breath and held, the machine automatically knew, and it went ahead with the test exercise. And then the second step in our read-on protocol is Booth bending over, and that's to test the pull of gravity on your fit, that impact of gravity on your respirator's fit to your face. So same thing here, he's going to wait that 30 seconds while he's performing that test exercise, which is now normal breathing while bent over. And then when that 30 seconds is over, he's going to initiate that test measurement. And it's going to run through the test. You can see again, maybe vaguely, the machine in the background changing to the test measurement. So our third step is just shaking your head vigorously while exhaling forcefully, or talking or yelling. And then you just initiate that test measurement. So it's going to run through that test measurement. The next steps, though, are to me what are most valuable about this protocol. And clearly it was most valuable to whoever named it, because it's called the read-on protocol. So these next two steps are read-ons of that respirator. So when you have a user perform this read-on protocol, they are effectively performing 3 donnings of their respirator, which to me just really verifies their ability to consistently achieve that passing fit factor. And it's one of the coolest things, I think, about controlled negative pressure. You wouldn't be able to do this with another methodology. So Booth is going to finish up his last step here, and you can see that, well, you can't see it, but I'll show you later the actual avatar working through those test steps to show our users the movements that are taking place for each step. I get so confused about, it's the step with the exercise, with the step, with the measurement, but then the whole thing's a test. Okay. So for our QuantaFit 2 experience, I think it's nice to see the test kind of in action before we talk about these upgrades to that user experience. We here at OHD had, I guess, the unfortunate opportunity to respond to some of the concerns that COVID created in real time when we were developing the user interface for the QuantaFit 2. So we're going to talk about some of these individually, but I want to point out the ones that don't have their own slides. So Bluetooth is going to allow you to test from across the room or even in another room entirely. And we just saw that auto start functionality that allowed for touchless testing. I should have pointed it out as he was testing, but hopefully you noticed that he didn't have to touch the machine, Booth didn't have to touch the machine at all. Actually, Luke didn't have to touch the machine at all either because he was operating it from the software on a computer. So we really can facilitate that distancing and limit the touching. I know we have the color touchscreen display, which you can touch, but you wouldn't have to in that instance. So the battery power is going to allow users to ultimately test anywhere. So our technology is already going to allow you, because you're just using air as the challenge agent, you can test anywhere. Clean air, dirty air, inside, outside. You don't need a special test environment to perform your fit testing, but you used to have to at least have a wall outlet, right, or some means of power. So this battery power is really going to allow users to test wherever they need to, and it's also going to allow you to space out your machines in whatever way is going to best protect you and your users. So you can see that the touch screen, I mentioned it's called touch screen, so it can be hand operated, and that's what Sarah here is doing. But you could also use a personal stylus because there is the option for the on-screen signature capture. And I don't know about y'all, I really think more and more people are carrying those around, and I do have one on my keychain because I don't want to, I never did like touching a lot of stuff that people have already touched. But the benefit to me of these on-screen animations is the guidance they help provide the user if you as the fit test administrator are kind of keeping your distance. I would say when I used to go out and give fit tests, I would be very descriptive, and I was having to basically perform the exercise for the person just because I wanted to have that clarity. Well, now a lot of that is coming from these avatars. And so each of these are actually representing very different protocols. So the one on the top is for the American Navy here. And so they have one step where they're bending over as they turn their head side to side. And so that's what that avatar on the top is doing. The one in the middle is for the HSC for the UK. And so with them, they're performing certain exercises at what they kind of call extreme. So with your head raised, and you're doing head down, there's a series of exercises. And then the bottom one is our read-on avatar for here in the US and everywhere else that's using that read-on protocol. So for this one, because you couldn't see that screen, I kind of wanted us to be able to like walk through what you would see because I do think it's pretty cool.
On your screen right now.
I'm so sorry. We actually don't want Booth talking there. So this is the screen that you would see on your QuantaFit 2. And it's hard to show you this through the computer. So this is actually a simulator. And well, it's actually a recording of the simulator. That's why you heard Booth for a second. And I usually do have that support here, but it's late night and it's also spring break here. But so you can go in and you can go to your system settings. You can go in, perform your daily verification. You can do some reports. Also, settings is where you're going to set up all your respirators, but you're also going to, of course, go in and do your fit testing. And this is all where you're would do this if you're doing the standalone mode. So you're going to select your respirator, you're going to select the size. We don't have the need right now to do a person or an operator. So we're just going to click ahead. This is where you're going to be able to see all of the test information that you just input, and you would see, you know, a name of the wearer. Then you would also see an operator where you would plug that in. But I also think it's really cool that now you're going to get an actual image of the respirator that you're using as kind of that visual last step to really see and make sure that you selected the correct respirator. Then also one step that you have to do with our test is to prop open that inhalation valve. And so I find this graphic really helpful, and our users seem to like it too. It also reminds you at the end to make sure that you've removed that inhalation valve, which I like. We also have more graphics about how to hook up your machine that really seem to provide some clarity for our users. And then this is what I was talking about, that avatar you would see. So you saw it for a brief second on the last slide. And so he's going to tell you what to do. He's got some instructions. And once he gets into the test, you're going to be able to see that. This is exactly what your user is going to see on the front of their machine. And they're going to take their short breath until their indicator, so their indicator would be in this box, and it would turn green. And once it turned green, they would know that they had held their breath enough, and it would initiate the test. And so we don't have to go any further into that. I just wanted you to see what the test was offering and see what the actual front of the QuantaFit 2 would look like. That was kind of in the background of that last slide. So the next aspect of the Q2 and like the changes that we made is the logic software. So this is just a quick screenshot, and this is an example of the report that would come out. And on the next slide, what I'm going to do is we actually are going to hear Booth talk this time. I'm going to allow him to talk. I really do wish that I had this power, I guess, in the real world, but.
Now, just so you can have a little exposure or a demonstration of what it would look like to have multiple units connected to one computer simultaneously, we could be right over here. We could grab Luke. We could put Luke in this 3M6000 series. His would be a medium. We could come right here, hit start, accept that, and now you can see it says rating right here. What you cannot see probably well is on this device. It is now moving into the screen where it's asking, is this Luke Allen? Are you in that 3M6000 series? Is it a medium? Okay, and this one says steps running because we've accepted that we have the right information. Now, we're going to quickly connect the instrument to the respirator via a set of tubes. Pretty simple with some quick connects right here. I'm going to jump in this respirator, and you'll be able to see me doing the OHD QuantaFit 2 Quantitative Respirator Fit Test. Now, before I do that, I want to explain this graph right here. The vertical axis is pressure. The horizontal axis is completion of percentage of completion of the testing process. When I engage the QuantaFit by drawing and holding my breath, you're going to see a line run up to that red line. That's the QuantaFit evacuating the air out of the respirator, using that scientifically validated breathing rate to evacuate the air out of the respirator. When it reaches that red line, the QuantaFit 2 is going to know that it's pressurized the mask to the degree that it wants. And what it's going to do is it's going to trace that red line. It's going to hold that pressure, and it's going to ask one pivotal question. How much air is penetrating or breaching the seal of the mask? That's how we're going to determine the fit and integrity of the respirator, whether it's good or not good. So let's jump in, show you that in action.
And don't worry, I'm not going to make you sit through another fit test. I've just stolen that clip here because I like where it's highlighting that we're testing the two people at once. It also does plenty to just show the software in general. And then I love that part where Booth's talking about what the machine's going to show you on that graph. Surprisingly, we get a lot of customers who, just aren't sure what the graph really is showing them. Another thing was we actually discussed taking the report of the leak rate off of the Q2. But in a beta test that we sent out, people just like seeing that leak rate, like knowing exactly what it is. So we love the graph. We like seeing our leak rate, And that's just what we found with our customers. And just for a little bit of edification with the running of 2 people at once. So Luke could start his test if that machine were in another room with Luke, or Luke were in there with Booth. Then Luke would be able to initiate his test whenever he was ready. Whenever he got his mask on, he could take his breath, and the test would go ahead and progress after he would have to confirm it was him and that he did have the appropriate mask selected. And then as you as the fit test administrator, you typically would not be fit testing yourself like Booth is, but you would have all these screens running, and if someone has something happen, like they fail a step, then that blue strip that has their name is going to start flashing red, and it's going to let you know that you have someone who needs your attention. And I just think that's really cool. So now I want to roll into the COVID realm of things. So this is something that I have had to make sure is clear. There's nothing inherent in fit testing that is protecting the user. People get a little bit confused because they're wearing a respirator and they think, oh, well, I'm wearing my respirator, so I must be protected. But there's also nothing inherent that's protecting the fit test administrator. So when you use your respirator in a quantitative fit test, it is either going to be with a probe or without the filters in place. And so it's basically just a superior facial covering during the test. And because they typically have an open exhalation valve, if we're talking about most of the elastomeric respirators, the operator is not being protected from exposure. So you are still being exposed to other people in the fit test process, and you should treat it the same way as being exposed to any other person, right? The risk is other people. So you want to apply the same principles to your fit testing that you've been doing everywhere, right? On top of that, some COVID considerations for fit testing that I imagine we'll see implemented just more in the future anyway. You might want to consider doing a health screening. You could consider temperature checks. And because your operator is the one who is going to be interacting with the most people, you may want to go ahead and have them in some PPE. The extent of that should be based on the situation specific to your site, right? Another thing is you want to really make any aspect possible virtual. So, you don't want to have them come in and do that health screening to then find out that they do have some sort of symptom. You want that health screening to take place before they've even come in. Even some of the training aspects that have to do with fit testing, it might be best to have those virtually and just have the fit test in person. As I'm sitting here running through my head, I'm like, man, you could just send the QuantaFit there and they could just do it. And but y'all are handling COVID a lot better than us here, so that's just where my head goes with what we should be doing. But anywho, base it on your site. If any symptoms are reported or observed, of course, do not perform that fit test, right? So maintain that physical distancing. Grant yourself some grace with your test timing. I know when I used to administer fit tests, I would, really just try to, how many people can I fit test and how quickly, still making sure that I did everything exactly right. I am a stickler for rules, but just how many people can I get in and out of here? So, but with this, you're going to want to grant yourself some grace with your testing time. Make sure you're keeping your space. I don't think I mentioned this, and I should have on actually the last slide, but be outside if at all possible. Maybe you can perform your fit testing in a big open bay. At the very least, you can open some windows. You're going to want to test one person at a time. You could even if you're doing what I was talking about, where you have different stations set up, right? You're going to have those stations spread apart and only have one person approach each designated space at a time and don't have them gathered together waiting to be tested, right? So just grant yourself grace on that time. Have, just a few people coming up to the stations, everyone else is away. Maybe they get a text like 15 minutes before they need to come up. But so then allow time for that space to clear out, even if it's just allowing it to clear out naturally before you invite the other subjects in or up. And use that time to wipe your surfaces. Everything about the QuantaFit, because we talked about the operator standing there unless they're in a respirator that's filtering their exhaled breath, which can happen with the FFR. So y'all P1s and 2s. I get so confused about the terminology, but so our N95s and up. But also now they're coming out with respirators that don't have the exhalation valves. And so if you had your operator in one of those where it's filtering the air on both the inhale and the exhale, then they would be being protected. But keep in mind that if the fit test subject is even wearing one of those, then like I said, because of how the test is performed, the respirator is not going to be functioning appropriately to filter all the air that it should be. So these are the top responses to the concerns that our customers have brought to us. And some of them aren't on here. One that we've been getting more frequently is just clarification that your barrier facial covering is not a respirator, and it cannot be fit test. It should not be fit tested because the fit test would not be very effective because of how barrier facial coverings work. They're primarily meant to be a method of source control, right? They're not primarily acting as any sort of personal protective equipment, although I don't want to get into the weeds about all that. But so these are the top responses to some of the concerns that our customers have brought to us, specifically to me. So the QuantaFit or the QuantaFit 2 doesn't trap air in the system. So when the subject tests, they're taking a breath of the surrounding area air, and then they're holding their breath while the machine pulls the pressure, and the air that it's pulling is that surrounding area air. So that's not to say that it's clean air, but it's the same air that's just existing in that space. So it may be contaminated, and we should in fact assume it is, right? But there's no added risk. The adapter doesn't have any hollow spaces. The adapters don't have any hollow spaces to hold air. And although the tubes do, they're open to the environment. And also the machine is only ever pulling air away, never pushing it towards the subject. And that being said, the adapters and tubing they should be wiped down because, like I said, they're still subject to the surface contamination, but they can even be submerged. They just need to then be completely dry before being used in a subsequent fit test. So these are some of the main things that our customers have come to us about. And man, y'all, I talked so fast. But so does anyone have any questions?
Thanks, Stephanie. Yes, we've got a few questions already, but if anyone does have any questions, if you just type them into the questions box and we'll try and address them all. So the first one from Jared was, can this be used for disposable P2 respirators?
So CMP cannot be used for the disposable P2 respirators. And actually, that's kind of a weird thing here in the US right now. I imagine, I don't know if y'all are still experiencing all of the shortages that we're experiencing here, but so our OSHA and CDC is recommending that for fit testing those disposables, that you use the qualitative method so that you're not damaging the respirator itself, and so that it can be reused, because they are recommending reuse right now, which is not something we would typically recommend, but because of those shortages.
Thanks, Stephanie. Yes, and another one, what respirator adapters for different models manufacturers are available?
Oh, I mean, tons and tons. I can't even get into to what's available.
Yeah, I think it's pretty much everything's covered, isn't it? There's a number of different
So,
adapters, and some
you know,
adapters fit different respirators as well. So you don't
well,
need.
and we're getting a surge of new respirators right now, specifically for the pandemic. So we're actively creating new adapters for respirators that haven't even been released yet. So.
Okay. And the next question, does the QuantaFit software generate fit test cards or certificates that can be issued to an individual?
So they do. And the one slide that had the image of the report, there's a little space on the bottom of that that's a fit test card, but it can also print off just cards.
Thanks. Next question, does the software/database have the capability to work across multiple sites that a company may have, i.e. save fit tests results across a server, or does each site have to manage an individual database which a company would have to then consolidate?
Okay, so I think that it's the latter, but that we're moving towards the former. So I think there is going to be that capability, but that currently there is not. And Peter, if you ever know more than me, you just say it, because I am I'm not like the expert on what we sell or what it's kind of weird. I'm like a tech support person, but I don't I offer suggestions for our software, and I work with tech support to move us in certain directions for development, but sometimes I'm a little bit behind on what's actually been released.
Okay, thanks. And a question from Brian, are many medical professionals wearing reusable respirators?
We had a ton move to reusable elastomeric respirators, and I actually see that trend growing. There was a report that was released well before COVID by the National Institutes of Health that was on the use of reusable elastomeric respirators specifically in healthcare, and they found all sorts of positives. I mean, they definitely found some negatives too, but all sorts of positives. It was ultimately cost saving, but the biggest learning curve was training the employees on the care and maintenance of their reusable respirator, which I think is easily overcome, since we would have to imagine that all these industrial guys that are doing it, if they can do it, then surely our healthcare professionals can do it. I think we all have that capability. So.
Thanks, Stephanie. And I've got a few questions from Paul. The first one is adapters for 40mm thread inhalation ports. Yes, we do have them. Does the exhalation valve need to be blocked?
No.
And is there a maximum fit factor?
Yes, and it's protocol specific. I believe for our read on, the maximum you would be able to get is a 26,900.
And another question is around calibration, actually. What's the cost of calibration and the expected turnaround? And I've got some good news there for anyone who's already using a Quanta Fit or looking at using them in the future, that we're in the process of setting up a calibration facility in Melbourne. So I can't confirm the cost at the moment or the expected turnaround, but it will be being done in Melbourne, which will be a great advantage over
And I have
sending
no idea I don't even know how much our instrument costs. It's just not something that, I'm so sorry. I'm not a salesperson, so I just don't know. I'm the worst.
Very good value.
Oh, please don't tell Luke.
Okay. And Luke's asking if reuse of disposable respirators, e.g. P2N95, is occurring due to shortages, should we also be undertaking fit tests for both new and used masks on the same person? RPE straps are definitely not providing the same seal after a few days use.
I mean, if it were me, I would want to, if I'm having those concerns, then I'm going to want to run a fit test, right? Like if I'm thinking that my mask is not providing the same level of protection, then why not just do the fit test? I know it's time consuming, but it seems like it's worth it in this instance. So that would be my recommendation. That is not something that's required.
Yeah, thanks, Stephanie. That looks to be all the questions. So if no one's got any more, I'd just like to thank you all for coming along today. I'm sure you've all found it very informative and interesting. If you've got any further questions on the QuantaFit 2 or QuantaCheck, please feel free to contact your local AirMet representative. And finally, thanks heaps, Stephanie, for your time this evening. For you, I really appreciate it. Really interesting presentation and some great new technology for fit testing. So thanks very much. Thanks, everyone.
Thank you so much.